Reaction, Boki. Rate of the reaction. 54.
Change in concentration of potential products per unit.
Wait. Right. Then they say, let us use the reaction between impure powdered calcium carbonate and excess hydrochloric acid to investigate the reaction rate. Now, that is a reaction that you are going to do on Monday. Monday is your practical Monday for marks. Wie was nog absent gister? Julle twee. Ja. Okay. So, alright. So, that's one of the reactions that we are going to do. Then they give that reaction for you, balanced equation. Then they say they perform 4 experiments under different conditions, mass and temperature as shown in the table below. Alright, so there you can see the 4 experiments. Let's see there, they have concentration of the acid. This one is 1, 1, 1, and this one is 0.5. So if we compare just the concentration, we think reaction 2 will be the slowest. Then they say the mass of impure. You can see 15, 15, 15, 25. What will happen there? Will it react faster? Maybe a bit. So let's say if I spread all of you out, this whole class, and I say you have 2 seconds to find a partner. Then you'll probably walk those 2 seconds before you partner up with someone. But if I double the learners in class, okay, now we have 20 learners in the class and I say spread out, it will take you 1 second to find a partner. Yes? Not a partner for life, just pair up. Okay? So, the more particles there are, yes, it will have an effect. It didn't change the concentration, but it will have an effect. A small effect on how fast you will find someone, but the bigger effect is it will determine how many products you will get. Because they say there at the top, way at the top, it's not here, they say excess hydrochloric acid. That means that calcium carbonate is the limiting reagent. It's the limiting reagent. You remember that? So it means the calcium carbonate will determine how many products will form. So if we have more calcium carbonate, we will form more products. Okay. And then there the initial temperature, 30, 30, 40, 40. We know that the ones that are warmer will react faster. Okay. Now they say the results of experiment 1 and 3 are compared in the investigation. Okay. 1 and 3. Let's check. Same concentration, same mass. It's the temperature that is different. Yes? 1 and 3. Okay, so they asked, write down the independent variable. Independent variable is the thing that we changed. What is that, Mama? Temperature. Dependent variable is the thing that we measure. What is that, Jabu? Yes, the rate of the reaction. Concentration is wrong. In this chapter, it will always be, the dependent variable will always be the rate of the reaction. Always. It doesn't matter what you're comparing, where, what, when, whatever. Always the dependent variable is the rate. Yes.
I thought it was the volume because they say they measure explain this for measuring the volume of the
You can also say that. So that is how they sorry. They determine the rate is how fast the volume is given off. So you can say the volume released. Okay. Then they ask, use the collision theory to explain why the reaction rate of experiment 4 will be higher than that of 3. So let's see 3 and 4. 1, 1, 15, 25, 40, 40. So what's the thing that is different? It's the mass. Meaning there's more particles. Okay, so Antoinette, that counts 3 marks. Give me what will happen.
I said experiment 4 will be higher than experiment 3 because the particles in there is sufficient kinetic energy and correct orientation.
Okay, you'll get 0. Okay. Like always in science, you must state what is the obvious difference between them. They have the same concentration, they have the same temperature. What is the difference? The mass is different. So you are going to state that. You're going to say the mass of calcium carbonate in 4 is higher than in 3. Now please don't use an arrow in a test or an exam. I'm using that to save time. Okay? What effect will that have? It means there's more particles to collide. Thus, reaction 4 will have more particles that can collide. Then that golden sentence. What is that golden sentence? Thus, near more effective collisions per unit time, thus the rate is bigger. So in science, always first. Killa, what are you doing? What are you doing? Oh. Did you get it? Okay, so always in science, first give the obvious difference. Okay, so what was the obvious difference? The one's mass is more. Then you say what effect will that have? Yes. Yes. Are you done? Okay, so then you ask what effect will that have? Well, it has more particles if the mass is more, and then the conclusion. That's more effective collisions per unit time. Okay, then they ask you, the learners obtain graphs A, B, C, D for their results. And then you must now say which one is 1, which one of them is for experiment 1. And then you must compare them with 2, 3, and 4, and it counts 6 marks. So you must fully compare. Okay, now let's just see here. We have one that is a lot more, and we have one that is very small. Okay, so let's eliminate those two first. Okay, the one that is a lot more than the other one, it looks a lot like B, but it just produces a lot more products. Which one of these 4 reactions will produce more products? What? I want to know which one, A, B, or C, fits with 1, 2, or 3. Which one fits with A? Experiment 4, because it has the most of the limiting reagents, so it will produce more products. So A definitely fits with 4. Okay, let's see D. You can see that there where it forms a horizontal line is where the reaction is finished. Okay, so D takes a long time before it finishes. Yes? Okay, so which one of these, well, definitely not 4, which one of these 3 will take the longest time to finish? 2. Experiment 2. Why? For 2 reasons. It has between the lowest temperatures and it has the lowest concentration. So D is 2. So we must figure out between B and C, which one is 1 and which is 3. Can you see that B is finished faster before C? C finishes here and B finishes there. There B becomes constant and only here C becomes constant. Okay, so you can see B finishes earlier. So B is faster. Okay, so which one between 1 and 3 is faster? Let's check. 1, same. This one is higher. So 3 will be faster. So 3 goes with B, 1 goes with C. Okay, but now we must fully explain why. Okay, so I'm going to explain like I did this. I first eliminated two things. I said there A goes with 4. Okay, so I'm going to say there 1.4. I'm going to say A goes with experiment 4. Why do I say that? And they say we must compare each one with experiment 1. Okay, so if we look there, what's the difference between 1 and 4? 4 has more mass and a higher temperature. Okay, so we're going to say experiment 4 has a higher temperature and a bigger mass than experiment 1. Thus, it will react faster and release more carbon dioxide. Right. Then we looked at D. We said D fits with experiment, was it 2? Experiment 2. Why did we say that? We said in experiment 2 has, if we compare 1 and 2 with each other, because we must compare everything with 1. They have the same temperature, same mass, it's just the concentration that is different. So experiment 2 has a lower concentration than experiment 1. Thus, it will react slower. Okay, then we're left with B and C. We said C fits with 1 and B fits with 3. So let's do first B fits with 3. What is the difference between 1 and 3? It's just that 3 has a higher temperature. So we're going to say experiment 3 has a higher temperature than experiment 1. Thus, it reacts faster. So then we say, thus, experiment 1 is represented by C. Mas você acaba assim.
So if you choose the wrong answer, but the whole explanation is right, is it the whole thing?
Right. Then the last question there, they say, When the reaction of experiment 4 reaches completion, the volume of gas formed is 4.5 decimeters cubed. Assume that the molar mass of gas at 40 degrees Celsius, why did they say 40? Because the reaction happens at 40, is equal to 25.7 decimeters cubed. Calculate the mass of the impurities present in calcium carbonate. Okay, so this is again, it's 5 marks, this is again the mole table. Okay, with mole table, what do we start with? Balanced equation. Okay, so we have calcium carbonate reacts with hydrochloric acid, and that gives you calcium chloride and water and carbon dioxide. Binne? Hallo.
Ek hoef dit vir vanaand.
Ja?
Juffrou, kan ons die groot speakers in die saal gebruik vanaand?
Bekom vanaand.
Vir die oop dag, juffrou, want ons video's en goed wat in die PowerPoint inspreek.
En die een die regte
Nee,
speaker
die oaks werk.
Ja, maar luister, we leer Lucian doen die bank vanaand.
Die ry.
Ja. Ja, dit is op sy werksverdeling. Hy is gesê om dit te doen. Alright. Okay, dankie julle. Okay. The mole ratio is 1 to 2, and that gives you 1 to 1 to 1. Okay, so that is just our recipe, okay? That is the mole ratio. Oopsie days. That's the mole ratio. Then we have beginning, change, end. Now they say there that the hydrochloric acid is in excess. I said it all the way at the beginning, so I'm not even going to worry about that. They give us the volume of carbon dioxide that is formed. They didn't speak about calcium chloride. They didn't speak about water. Since hydrochloric acid is in excess, it means that calcium carbonate is our limiting reagent. So we have nothing of that left at the end. And carbon dioxide is a product that is formed. So we start with 0 of that to begin with. Okay, right. Now, what other information do they give us? They say we have impure calcium carbonate, and that is 25 grams. But that is impure. Are we allowed to put impure in our table? No. Then they say the carbon dioxide that is formed is 4.5 decimeters cubed. But this here is our mole table. We're only allowed to fill in mole here. So we have to first convert that into mole to fill that in there. Yes? Okay, so we're going to say mole is volume over volume or the molar gas volume. That is 4.5. And they say the molar gas volume they give us as 25.7. You get a mark for the formula and the answer. 0.17510. Okay, remember it's not your final answer, so you can't round off yet. Okay. Right, so here at the end we have 0.1751. So if we started with 0 and we got that at the end, then obviously that is how much we gained. Then our mole ratio is 1 to 1. So are you guys done? You can go. So if that is how much we gained, then that is how much we should have used here. Now if you don't use a mole table, then you can just show it's 1 to 1. You can just show it like this. 1 to 1, and then give it like that. Okay. But if you write the mole table and your mole table is neat, then they will go look for that mark in your mole table. Right. So if we have 0 of that at the end, and we use so much, then it means we had to have so much to start with. that which we have there, that there, is our pure mole of calcium carbonate. What was the question again? The question is calculate the mass of the impurities. So what are we going to do next? Anyone? Yeah. Yeah.
So I use those moles, and then I substituted into the n equals 2 mass over molar mass, and then I've got an answer.
What is your mass that you got?
6.6.
No. Calcium carbonate. Calcium is 40, carbon is 12, and 3 oxygens. That is 100.
I multiplied it
With?
with the n
Where?
to get the m.
But did you say 600?
Ish, ma'am. So
Okay. That's 17.51.
when I got the answer, I didn't know what to do.
Okay. So if you get to that answer and you don't know what to do, you ask yourself, what did I just calculate? That was the pure mole. Oh, sorry, it's the M, yes? Thank you. That is the pure mole. Right? So if I use the pure mole, what is that I got? That is the pure mass that you've calculated. Okay, so I think you would get up till 4 marks. So what is that last mark that you're missing? They're asking what is the mass of the impurities, not the pure stuff, the impurities. Okay, we know the total mass was 25 and the mass of the pure substance is 17.51. So how are you going to get the impurities? Subtract. So you're going to say the mass of the impurities is going to be 25 minus 17.51, and that gives you 7.49 grams. Okay, you can see there the answer is in brackets. They give it to you as 7 grams, but that is because they rounded off there at the beginning. Okay, so in a test or an exam, they'll give you a range. They'll probably take from 7 until 7.5 grams or something like that. Okay. Are we sharp? Should we do one more?
Yes.
Okay. Yes.
We didn't finish number 6 of question 13.
So we didn't finish number 6. Okay. So can I go away here? So I'm going to go to yesterday's work. Yesterday we did this reaction here on page 62, question 13. Okay, we looked at all of them. We stopped at 13.4.2. Okay, so let's go to 13.5.1. They say experiment 6 is now conducted, so that's a new experiment, using a catalyst at the same reaction conditions as experiment 1. What is the function of a catalyst in this experiment? What is the function of a catalyst? To speed up rate of reaction or reaction rate. Okay, 13.5.2. They ask, how will the heat of the reaction in experiment 6 compare to that in experiment 1? Choose from greater than, equal to, or less than. The heat of the reaction. Heat of the reaction. What symbol goes with heat of a reaction? Delta H. Okay, so this is where they ask you the grade 11 work. Now, this reaction is an exothermic reaction. So let's say the reaction would have looked like that. Okay, normally. So if you draw an endo-exothermic graph, this is an exothermic graph. Okay, if you use a catalyst, what does a catalyst do? It speeds up the reaction by doing what? By lower the activation energy. So what a catalyst does, and this is what we did last year, it will only go up until there, and then it will go down. Okay? So what a catalyst does there, so that is a catalyst, and what does it do? It lowers the activation energy and it speeds it up. So it ends fast. Faster. Okay, but what is the heat of the reaction again? A heat of reaction is the change there. So with our blue line, our regional one, let's say this is 50 and this is 0. Then the difference there is 50. And for the red line, what's the difference? The same, 50. So a catalyst will do nothing to the heat of the reaction. Nothing. It speeds it up, it lowers the activation energy, but the outcome is still the same. So that is why the answer will be equal to. Okay. Then question 13.6. They say, calculate the average rate of the reaction in moles per minute with respect to zinc for experiment 2 if so much zinc is used. 4 marks. Okay. So they say we must get the rate, and they say the rate must be in moles per minute. What does that mean? Our equation will then be the change in mole over the change in time, because it must be in moles per minute. Right. The time they give us there for experiment 2, look at experiment 2, they give us there 14 minutes. Okay, so we know what the minutes is. It's 14. Do we have the moles? No. Okay. What they tell us there at the beginning is we have excess hydrochloric acid, so it's too much. So the zinc is our limiting reagent, meaning zinc will be used up. So maybe make a note for yourself there. Hydrochloric acid is in excess, thus the zinc is the limiting reagent. Okay. So they say we must do it in respect to zinc for experiment 2, and they say 1.5 grams of zinc is used. They say the mass there is 1.5 grams. We don't want mass, we want moles. So we first have to convert the mass into moles. The mass is 1.5. What is the molar mass for zinc? 65? 65. And that gives you 0.023. So that is the mole that was used. So now, if we calculate the rate, which will be the change in mole over the change in time, change is final minus initial. Yes? So how much zinc will we have at the end? Final. 0. Minus, at the beginning we had 0.023. And that happened in 14 minutes. So 14 minus 0. Ja, Jabu? Yes. Are we allowed to have a negative? No, so we are going to go up. We're going to say, make that a negative, put there a negative in, and then this changes to a positive. And our unit is moles per minute, like they ask in the question. Yes.
Question 5.1. 13.1.
Yes.
How do you know if they want you to explain what a catalyst does? Because when they said, what is the function of a catalyst, then just explain.
They're basically asking the definition of a catalyst, but informally. That's why it counts 1 mark. So it speeds up the reaction. But what did you say? No,
So the catalyst will lower this experience activation stage.
perfect. Okay. So for the last one, do you want to do question 14 or question 15? So 14. Every question in this chapter has a graph. 15 has difficult calculations. Do you want to go through that? Okay. Let's go then to question 15. Okay. So we're at question 15. That is on page 63. Okay. They say there, the calcium carbonate in anti-acid tablets like enos and what reacts with dilute hydrochloric acid according to the following balanced equation. There they give you equation. Now at the end of that equation, calcium carbonate plus hydrochloric acid gives you calcium chloride and water, and then they say that is lower than 0. Now they ask you, is the above reaction exo or endothermic? Give a reason for your answer. What is it, exo or endo? How do you know it's exothermic? Delta H is smaller than 0. What does that mean? It means that the enthalpy is negative, meaning it releases more energy into environment. Okay, now you didn't have to give all of that. You could have just given that first part. Okay, but they can ask you for more marks to explain. That's why I'm giving everything. 15.2, or before that, they say there that an anti-acid tablet of mass 2 grams is placed in hydrochloric acid. So they say the mass, not just calcium carbonate, but the mass is 2 grams. 2 grams. So that's not pure calcium carbonate. It's calcium carbonate and other stuff. It's 2 grams. So place it in hydrochloric acid. After 30 seconds, the mass of the tablet is found to be 0.25 grams. Okay, so that's at the beginning. At the end, the mass is 0.25 grams. And that is in 30 seconds. Now they ask you at 15.2, calculate the average rate in grams per second for the above reaction. Okay, so the rate, and they say that in grams per second, so it's going to be the change in mass over the change in time. Okay, quickly see if you can do it. Okay, you do it on your own. Declan, what are you reading so much?
No, fine.
You haven't written anything.
Mom's in the public.
Chop. Do you know where we got the values, Declan?
Yeah, from the reaction.
Yeah. Yes.
0.25 is the initial. What to find out minus
0.0. Yeah. Okay. Now at question next one they say there. The antacid tablet contains 40% calcium carbonate. So of that 2 grams, only 40% was calcium carbonate. Another antacid tablet of 2 grams is allowed to react completely with hydrochloric acid. Okay, completely means all of it. Finish klar. 15.3. Calculate the volume of carbon dioxide that will be collected at STP. Do you remember STP? Yes. Standard temperature and pressure. Assume that all the carbon dioxide produced is from the calcium carbonate. Okay, right. So if we go back to our table. Are you writing down? Okay. They say again we start with 2 grams of that. They're saying we are at STP, then we can use that. Okay. They say completely, so it means we have, mole ratio. 1 and highlight. Then we have mole, beginning, change, end, blah, 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 blah. So it acts completely, so it means all of the calcium carbonate is used up, so that is in excess, yeah.
Is there a small
Big V. Okay, they didn't ask anything about calcium chloride, they didn't ask anything about water. We know we start with 0 carbon dioxide, and because it is allowed to react fully, completely with hydrochloric acid, it means we have the 0 of the calcium carbonate at the end. Okay. Now, can we just convert this 2 grams into moles and put it in our table? No, because that 2 grams is not completely calcium carbonate. Only 40% is calcium carbonate. So we first need to say, okay, what is the mole? Not the mole, the mass of calcium carbonate. It is 2 times 40 over 100, or 2 times 40%. 0.8 grams. But now we have grams. We need to convert it into moles. A mole is mass over molar mass. 0.8. What is the molar mass of calcium carbonate? We just did it. 100, because it's 40 plus 12 plus 3 times 16 gives you 100. And that gives you 0.008. Okay, so that is what we have at the beginning, 0.008, and we're going to use all of it. And the mole ratio is 1 to 1, so it means we gain 0.008 here. Okay. We have now the mole of carbon dioxide and we want the volume. For that, we're going to use this formula. The mole is 0.008. We want the volume, and they say we're at STP. So this is 22.4. And that gives you 0.18 decimeters cubed. Okay, so you can see here the mole tables aren't that difficult. You don't have to fill in a lot. Only compare two things. One is always a limiting reactant. You just need to read. What is wrong, Mama? When I said it's not difficult, you smiled. You did, but it was, never mind. Okay, you were just happy. That is true. Okay, then the next question there, we're almost done. They say there we have a graph of 1 over time versus temperature. And you can see it goes up like that. They say another reaction similar will react with excess hydrochloric acid with that concentration at different temperatures. Okay, now they ask, write down one controlled variable for this investigation. One thing that was kept constant. What is that? They say at different temperatures. Was the temperatures controlled? No, the temperature changed. There's a few things. They say there you have excess hydrochloric acid the whole time. You have a concentration of 0.1. I think that's about the two. That's what they give us. They say the reaction rate is similar antiacid tablets with excess hydrochloric acid. So that's the whole time hydrochloric acid excess with that concentration, but at different temperatures. So the temperatures was not constant. Okay. Then they ask at 15.5. Write down a conclusion that can be made from the graph. Okay. Now, 1 over time there, when we calculate our rate, for example, is the change in concentration over the change in time. So when they give you something like that, that refers to the rate of the reaction. Okay, so write down a conclusion that can be made from the graph as the no, just that. As temperature increases, the rate or the 1 over time will also increase. Okay, then 15.6. Use the collision theory to fully explain the answer to question 15.5. Now we're going to do that sentence. Mama, go for it. Why do you say the time? No, as the temperature increases, yes, the kinetic energy of the particles increases. Yes? Sufficient kinetic energy, yes? Decisions per unit time. Okay. Then they ask us question 15.7. Redraw this graph. Oh, and on the same set of axes. Okay, so there, 1 over time. And this is the temperature. Okay, so this was our original one. Now they say we must draw it again if 0.2 mole concentration was used. Okay, so we originally had at the beginning we had 0.1 and now we have 0.2. What will happen to the rate? Increase. It will be faster, 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 faster. Right? So now you are going to go faster, 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 faster.